Hello everyone. In this video, we will understand the recommendation system in very simple way. We will cover similarity measures like cosine similarity, Manhattan distance, and inclined distance. Then we will learn context-based filtering, etc. What is recommendation system? A recommendation system is a system that suggests useful or relevant items to user. These items can be movies, products, songs, videos, or books. It is used in many real world applications like Netflix for movies, YouTube for videos, and Amazon products. The main goal is to help users to find what they like. Recommendation systems are important because they save users time. Instead of searching manually, the system suggests related items directly. They also improve users' experience because users get personalized suggestions. For companies, recommendation systems increase engagement, sales, and customer satisfaction. What is similarity? Similarity means measuring how much two users or two items are alike. In recommendation system, similarity helps us find which items are close to a user interest or which user has similar taste. This becomes the base of the making recommendations. Comma similarities of measures. There are many ways to measure similarity. Three common methods are cosine similarity, Manhattan distance, and equivalent distance. Cosine similarity tells how similar of two vectors are in a direction. Manhattan distance and equivalent distance measure the distance between 2 points. In recommendation system, smaller distance as usual means more similarity. So here we can see for your more easy way of understanding, we have two like cat and dog. Like we have the array of the cat, like the size of a nose, the size of a face, and the ears, etc. The movement, like the nose and eyes are near where there are so many features. So in that way, I have just taken a small example like cat and dog. So here we can see two vectors, one cat and one dog. In cosine similarity, we will measure the angle between two vectors, whereas in Manhattan distance, we will measure the distance. Equivalent distance, we will measure the smallest distance. In more similar way, visual way, you can understand by this help. See, in Manhattan distance, you can measure like from x1 to x2 and y1 to y2. This is the Manhattan distance. Whereas equivalent distance from x1 comma y1 to x2 comma y2. So here we can see the formula, like a simple equation form. Like we can see like x2 for L1, the x2 minus x1. Like Manhattan distance will be calculated with this help. Like x2 minus x1 plus y2 minus y1, this one, equal to L1, that is Manhattan distance. Whereas L2, we will measure the distance like root over x2 minus x1 whole square plus y2 minus y1 whole square. Cosine similarity. This is the definition. Cosine similarity tells how much two vector points in the same direction. Higher value means more similar. It is the normalized dot product of two vectors. We can see the formula, and here how we calculate. Like for example, x is equal to x1, x2, so on x1, and y is equal to y1, y2, and so on yn. So dot product is calculated by in the way x1 into y1 plus x2 into y2 plus so on, and here x is equal to x1 square plus x2 square, so on xn square. Like this, we in the end we will get the cosine formula. There is also the manual way of calculation in upcoming slides, so there you can understand very well. And Manhattan distance. Manhattan distance is the distance measured along the axis. It is also called city block or taxicab distance. Smaller value means more similar. In recently in visualized way we have already seen how Manhattan distance are calculated. It's same formula: x1 minus xy1 plus y x2 minus y2 modular plus x3 minus y3 and so on. Euclidean distance. Euclidean distance is the straight line distance between 2 points. Smaller value means more similar. And in recently we have seen how it is calculated. And here we can get understand more clearly how this really works. So for example, we will take a real world example like mobile features and what user expectations. Based on user expectations, what similar mobile product is available. So with the help of this similarity like cosine, Manhattan, equivalent, we will suggest which mobile would be good fit for the user. So for example, user wants a mobile phone with these features like camera should be 5 on 5, battery can be 4 out of 5, storage could be 4 out of 5, and user vector will be 5 comma 4 comma 4. And there are two products available, phone A and phone B. Phone A features are camera is 4 comma 4, battery is 4 comma 4, and storage is 5 comma 4. And phone B 2 comma 5 comma 3. So these are like camera, battery and storage. We will try to calculate this one with the help of cosine similarity. So based on how we will calculate for phone A, we will calculate cosine similarity with user like 5 comma 4 comma 4, 4 comma 4 comma 5. So the dot product first we will calculate like 5 into 4 plus 4 into 4 plus 4 into 5, that is 20, plus 16 plus 20, that is 56. And the magnitude of the vectors u, that is user, like root over 5 square plus 4 square plus 4 square is equal to 25 plus 16 plus 16, that is root over 57. And the magnitude of the phone A, that is 4 square plus 4 square plus 5 square, that is 16 plus 16 plus 25 is equal to root over 57. The final cosine value is 56 by 57 into 57, that 56 by 57, that is approximately 0.982. Similarly, we will calculate for phone B, that is 5 comma 4 comma 4, and phone B that is 2 comma 5 comma 3. The dot product of user and phone B is 5 into 2 into 4 into 5 into and 4 into 3, that is 10 plus 20 plus 12, that is 42. And the magnitude of the user, that is root over 57, which already we have calculated here. And the magnitude of the phone B, that is root over 2 square plus 5 square plus 3 square, that is root over 38. The final cosine similarity between user and the phone B is 42 by root over 57 into root over 38, that is approximately 0.903. So here phone A similarity is 9.82 and phone B similarity is 0.903. Here, so the in cosine value, the more value is, the more similar it is. So phone A is more similar. Similarly, we will try to calculate for the Manhattan distance. So between user and phone A, the Manhattan distance is 5 minus 4 plus 4 minus 4 plus 4 minus 5, that is 1 plus 0 plus 1 is equal to 2. The between user and the phone B, the Manhattan distance would be 5 minus 2 plus 4 minus 5 plus 4 minus 3, that is 3 plus 1 plus 1, that is 5. In Manhattan distance, the less the value, the more similar. So phone A is 2 and phone B is 5, that is then phone A is the better choice. Similarly, we will try to solve for a similar example for Euclidean distance. Euclidean distance between phone A and user, root over 5 minus 4 square whole square plus 4 minus 4 whole square plus 4 minus 5 whole square, that is 1 square plus 0 square plus minus 1 whole square, that is 1 root over 2, that is 1.414. And between user and phone B, equivalent distance would be 5 minus 2 whole square plus 4 minus 5 whole square plus 4 minus 3 whole square, 3 square plus minus 1 whole square plus 1 square, that is 9 plus 1 whole root, that is root over 11, that is 3.317. Also, we have already told the more the less the distance value, the more it is similar. So phone A is 1.41 and phone B is 3.317. That is, phone A is the better choice. This is the manual way of calculation and comparison between cosine, Euclidean, and Manhattan. Hope this is very simple. Like, we have selected very few features, that is only camera, battery, storage. In real world there will be most of the features, and more the features will be, and the more calculation will be there. And we can see in all three cases, phone A, like cosine, Euclidean, and Manhattan, three of them suggested the one, that is phone A. In this way the calculation really works. Yeah, here we can see cosine similarity has given 0.982, 0.8. In only cosine similarity, the more value is, the more similar, but other two cases, the less value, more similar. Phone A, phone A, phone A. So these are the comparison, like cosine we already discussed. It's between the angle, the focus on angle, and Euclidean, the cosine most of the best use cases are text classification and recommendation systems that we are already doing. And Euclidean distance are mostly calculated in clustering, that is k-means, continuous data, etc. And Manhattan distance, that is high dimensional data, outer layer ribbons, etc. So now we will do an hands-on on Python code, where we will take real world problem, and we will try to solve it. So here we will see the hands-on section. Like, we will take an restaurant recommendation system. Like, we will recommend the restaurant based on the venue, distance, cost, etc. many features. So to save the time, I have already pasted the code. Anyhow, I will provide the GitHub link in my YouTube description. There you can see the full length code, and you can do hands-on, like you can practice this code. So here, first we will load the CSV file, that is I will give a basic context of the file, like on what we are going to work. So we are going to work on the restaurant dataset. Like, we will see types, so like the place where it is, and the things we are going to work, similar, like French, Japanese dessert, Japanese seafood, Asian, etc. Like, we will suggest the similar restaurant. Based on one restaurant, we will provide three types of similar restaurant. So this is our task. We are going to work on it. So here, first we will load the dataset. This is user for loading the dataset. Like, we are using Kaggle dataset. Here is the Kaggle dataset which we are going to use. Here I can show you. Yeah. So this is the Kaggle dataset which we are going to use it. This is the dataset we are going to use, and yeah. So we will first load the dataset from the Kaggle, and this is the part we are going to with the help of pandas. We are going to load the dataset. and after that we will select only few columns which which are required for us. Because it's simple similarity check, we will only concentrate on only few things. We will exclude other things which are not necessary for us. So here we are only important columns that we are taking: that restaurant name, city, cosine, average cost of 2 persons, price range, aggregate rating, and votes. So after taking only a few important columns, this is the thing. So as we know, as we already saw the array that cosine already like for cosine similarity, Manhattan, and many other thing also we have saw. uh, it's mostly worked on the what we call numerical. So here also we need to convert this text format into numerical format. So to do that, first we will see the most important column is this one. That is where we will first convert that into a list format. Here we are using lambda apply and lambda function, where we will convert that into French, Japanese, and this is the format. Later, because why we are converting this into list format, because it will be useful for upcoming multi-label binaries, where we will convert that list into a matrix, like numerical format. Like it will create a n number of matrix, and it will it's like the multi-label binaries. What it does is it will take all the available text, like keywords like French, Japanese, etc. It will create a whole matrix, and it will like what at, for example, for first row, which is like if French is available, there it will give 1, Japanese 1, desert 1, and all other things it will give 0. Like here we can see 0 0 0 0 0 0. For example, somewhere in the 2, 1 is given to Asian. So in 2 we can see Asian is present. So here how the multi-binaries it works. Why we are doing this? For more convenient for cosine similarity, Manhattan distance, and etc. So here we can see, and later like how does it works is, see, first MLB like import the multi-label binaries, and we transform the particular column, like this list column, and train that, and there we will take the index of same this index only, because not to interchange the rows, because it will be helpful for combining the df dataset and this newly created dataset equally at same index point level. And this is the inbuilt feature, like inbuilt class, where it will give the number of how many number of vocabulary are there, why how many text are generated, like how many these texts are created. So why we are doing, because with that help we will get in a column, like in an order wise column names, so for our better help. After that, what we will do, we will create a final data set. Like we will drop the column of city, like city also not usable, like it's text format. There we will we already converted this into list and list to this thing, so we no need of these 2 columns also. We will drop those 2 column also, and after that we will concatenate this column and the dropped column, like the features and the new this one, and drop NA for null values. And we will what we will do now, after doing this, the only text column that is present is restaurant name, and based on restaurant name only we are going to suggest other restaurant. So what we will do, we will convert the restaurant name into index form. So we will do index, like we will convert this into index. So other columns will be the other thing will be as being column only. We will convert this restaurant name. Why we are doing this? Because while converting into cosine, we will get an n into n matrix, the number of restaurant names and number of restaurant names. In upcoming code you will see how this will work. Yeah. And final data set, like this will be the final data set, that is all are numerical only. Then we will, without scaling means we are not normalizing the data set. Like see, here some thousands in value, here only in one decimal value, here also one decimal, here also hundreds value, here again one decimal value. So we are not normalizing it. So what the need of not doing, what need of doing normalizing? So we can normally do cosine similarity. Like normally we are doing the cosine similarity, what the drawbacks we will see upcoming. So here after doing this thing, see n into n matrix, here restaurant name, here restaurant name. See the here how similar this one and this one is 1, because highest value is 1, so it's most similar. Similarly, how this one is similar to this one is 0.98, how this one is similar to this one, that's 0.977. so here like this, same here, so it will create an matrix of n into n. That's why here in columns also we have given index of this previous full data set only, because we are converting, it is going to convert into n into n matrix. So here we can see the shape where yeah, not here, it's only showing. Actually we will get so okay, it's only, actually it's rows are 1000, I have only printed the head, so rows are only 5 and columns only 149, sorry. So while we can see after doing, it's 9542, rows are also 9542 only, but only I used head, so it's only giving 5 rows. And now so we will use recommendation, like first we will see like given a restaurant name and also matrix, that is this data set, and top 3 values which are similar. So we will see the restaurant is in the restaurant name is in the index, that is this thing. If the restaurant name is not present in this index, that means the restaurant is not in the data set, so we will print restaurant is not found in the data set. If it is there, then what we will do, we will based on this matrix, we will sort the values in descending order, not ascending order. Why descending? Already we have discussed, the more value is, the more similar in cosine. So from we will come to high to low, so that's why we are keeping ascending as false, we are sorting it as in a descending order. So here, and we are skipping 1. Why we are skipping 1? Because we already saw here first similar of the restaurant is itself, that's why it is 1. Other will be come later on, so the first similar restaurant is itself, so that's why we are skipping the 1, like 0 and starting with 1, 0 index and we starting with 1, and we are giving top n plus 1, that is 3 plus 4, that is that is 3 only. Yeah, so here the suggested cosine are these things, like this restaurant, this restaurant, this restaurant. But what you will see here that shocks you, so if we see normally in restaurant, like we will see restaurant these which it is given, then we can see French, Japanese, dessert, but here North Indian, Mughlai, Chinese, here North Indian, Mughlai, Chinese, here why we have given like we have done correct only, right? Then why it is giving wrong way cosine similarity? Because due to we not done the normalization, that is not we not done scaling, it will the major value will dominate. Here major values are these things are the major value, here are the major value, here are the major value. Then that you can see, like here similar values are given, here similar values are given, here similar values are given, rather than this, because this is less dominated than the high value of this. To overcome this, we need to do scaling. For scaling, we will use min-max scaler. Why min-max? It will give us a common range from 0 to 1. Min-max scaling. Here we will do min-max scaling, and we will see 0.00, 0.00, 0.97. So here in all columns the value will be in the range of 0 to 1 only. Now we will again see with the cosine similarity after doing the scaling. So this is the cosine similarity that we have got, and after we will see the suggested restaurants after doing scaling. So these are the suggested restaurants. Okay, here I didn't saw the show the restaurant names. So once again I will show the restaurants so you will get better idea. So this is the suggested thing. And this restaurant this is the okay. Yeah, 3 are enough. So here we can see French, Japanese, desert. Japanese there, French there, and desert there. So these are the similar restaurants which are similar to this restaurant name. So here after you can see the difference after doing scaling, right? Hope you are getting it. So that's why it's very important to do normalization before doing cosine similarity on Manhattan distance, these things, because the major value will dominate more. So that's we already seen one example also without doing scaling what is the output, after doing scaling what is the output. And similar way we will try to code for equivalent distance. This is the way where pairwise distance, which is imported by the here we already imported all the things like escape, preprocessing, multi-binary, min-max scaler. This is for normalization, and this is for cosine similarity, and this is for the pairwise distance. Pairwise distance, in this we already have Euclidean, Euclidean, and also Manhattan. In metrics, if we keep Manhattan, then it will work for Manhattan. So there we are. Yeah, Euclidean distance. So here we can see Euclidean distance. So we have kept data frame. So here also same index, and same columns also same index, because it's also n into n matrix of restaurant into restaurant names. Similar way. We already told, like we already discussed that in Manhattan and Euclidean distance, the more less value, the more similar. So that's why here the same restaurant name having 0 value. That's why we are having 0 value, because less the value, more similar. So recommendation here, the major difference between the cosine similarity recommendation and here Euclidean and Manhattan is, here we will sort values normally, like ascending order, not descending order, because the less the value, more the similar. So here we will see, so we have got the restaurant names for similar to cosine similarity, same restaurant names. And Manhattan distance also we will do same way. In here the major changing is metric is equal to Manhattan. Here metric is equal to Euclidean. That's the only difference between Manhattan and Euclidean code. In same way, we are giving the index, the columns of same restaurant, and then as we have distance, the more less the value, the more the symbol. That's why the restaurant having zero value with the start. In similar way, here also sorting the value in the ascending order. So see we can see it has suggested the same as the cosine similarity suggested the restaurant. So here also you can see I have kept the all three methods together. That is, these are the restaurant that cosine similarity suggested. This thing same way, equivalent distance also suggested. Same way, the Manhattan distance also suggested. Same band. Here the difference is less. Here more. Here less. That's the difference. Yeah. Thank you. So you can, if you want to do the coding stuff, I will give the GitHub link down itself, and you can go through it, and you can in Colab or in Jupyter you can code, like you can see the code and you can type it, and you can the more you practice you will get more idea how the code is working and how things are working. Yeah. Thank you.